how you did with these first two. So we're looking at congruent. 5 to the 152, well, you probably want to go to 5 to the 12th, right? And how many of those can we get without going over 152? 12, yeah. And it'll be times 5. This is 144, so that's going to be 8 mod 13. And what is 5 to the 12th mod 13? According to Fermat's theorem. 1. So 1 to the 12th times 5 to the 8th. So we still have to do 5 to the 8th, unfortunately. So let's do 5 squared to the 4th. And 25 is what? Compared to 26. It's 1 under, isn't it? So negative 1 to the 4th, mod 13. I get 1 mod 13. Who got 1 mod 13? We okay with that? Or are you using it for a calculator? Oh, okay. You can use it for a calculator. Okay, so then next one, let's do this one. 4 to the 56 is going to be 4 to the 6th to the, let's see, 9. 54 times 4 squared, mod 7. Ooh, I like this one. So this is going to be congruent to 1 to the 9th times 16, mod 7, and 16 mod 7 is just what? 2. Pretty cool. Let's do the solving one next. Okay, for solving, 3x is congruent to 5 mod 7. So what we're going to do is we're going to multiply. And just a quick reminder, 7 does not divide 3, and 7 is prime. Okay, so then we're going to take 3 to the 7 minus 5, 3 to the 7 minus 5.
I don't know.
Oh, you're right. I went too far. I was thinking what the answer is. It's 7 minus 2 instead of 7 minus 1. And then when we multiply it by 3 to the 1, this will be 3 to the 7 minus 1 times x is congruent to 3 to the 5th times 5 mod 7. What's 3 to the 6th mod 7 going to be? 1. And then this is going to be 3 squared times 3 times 5 mod 7. 9 is 2 mod 7, 2 squared. 15 is what? Mod 7. 15 is what? 3 times 5 is 15 compared to 14, which is 1, mod 7. So I think this is just going to turn into 4, mod 7. Like it. All right. Next. I'll put the right numbers in this time. So 13 does not divide 8 and 13 is prime. So I'm going to do this right this time. 8 to the 13 minus 2 times 8 to the first, x is congruent to 8 to the 13 minus 2 times 3, mod 13. This is just going to be 8 to the 13 minus 1 times x, 8 to the 11th times 3, mod 13. So this is 1, so it'll be x is congruent to 8 squared. Well, what is 13 times 5? Let's see. 65. And this will be 64, right? This is going to be 5, though. This is going to be 5 times 8 times 3 mod 13. 64 compared to 65, then this is going to be congruent to negative 1 to the 5th. 24 is going to be what compared to 13? Negative 2 mod 13. So this is going to be congruent to negative 1 times negative 2 mod 13, which I get as 2 mod 13. 2 is your answer. I'm going to tag this last part looking at determining primes. If a to the p is congruent to a mod p when p is a prime, what if a to the n was not congruent to a mod n? Okay? So in other words, if a to the p is congruent to a mod p, let's do the complete opposite. A is not a prime, or a to the n is not congruent to a, then n is not a prime. And that is what we want to be able to check. So if we took this example 123, all you have to do is take 123. Let's just do one. I hate to do one from the assignment because there aren't that many, but let's just do 63 here and see if 63 is a prime. Okay? So to see if 63 is a prime, you're just going to go 2 to the 63rd. 2 is the smallest prime, that's what we want to use that, is going to be equal to 2 to the 6th to the 10th times, what is that, 2 cubed mod 63. We're trying to see if 63 is prime. Okay, when we're all done, what we should get is 2 should be congruent to 2 mod 63. That's what we should get. To the n should be congruent to 2. So we use a 2 because it's a handy number. It should be congruent to 2. If it's not congruent to 2, then it's not a prime. So let's see if that's the case. All right? So this is congruent to, let's see, 2 to the 6th is 64, correct? So 64 mod 63 is what? 1 to the 10th times 8 mod 63. Okay? So 2 to the 63 is congruent to 8 mod 63. Is this prime? 63 is not prime because 2 to the 63rd is not congruent to 2 mod 63. 8 is not the same as 2. Therefore, 63 is not prime. You know, we can take an easier, let's do 21. And you could try that. 2 to the 21 is congruent to, and then you could break that up, mod 21. And you can see how that works. I'll finish this example. So this is going to be 2 to the 5th to the 4th times 2 to the 1st, which is congruent to 4 to the 4th times 2, mod 21, which is the same as 4 squared squared times 2, mod 21. 16 is going to be negative 5 squared times 2, mod 21. 25 is going to be 4 times 2, mod 21. And so we get 2 to the 21 is congruent to 8, mod 21. This is not equal to 2 mod 21. Therefore, 21 is not prime. And that's how you do those.